we're going to talk about chemical formulas and how to determine the molecular formula and the empirical formula. The molecular formula is a chemical formula that shows the number of different atoms present in a molecule. So the molecule P4O10 means it has 10 atoms of oxygen and 4 atoms of phosphorus. The molecule C6H6 means that there are 6 atoms of hydrogen and 6 atoms of carbon. The empirical formula is a chemical formula that shows the composition of a compound given as the simplest whole number ratio of atoms. So that just means that the subscripts have to be reduced in the lowest form. So if we take a look at the molecule P4O10, the subscripts are 4 and 10. The common factor between 4 and 10 is 2. So 4 divided by 2 is 2. 10 divided by 2 is 5, so the empirical formula is P2O5. The molecule C6H6 has the subscripts 6 and 6. The common factor is 6, so 6 divided by 6 is 1. My empirical formula is CH. The molecule C2H4O2 has subscripts of 2, 4, and 2. The common factor is 2, so 2 divided by 2 is 1, 4 divided by 2 is 2, and 2 divided by 2 is 1. So my empirical formula is CH2O. Let's take a look at an example. Determine the empirical formulas for the following compounds. N2H4. The subscripts are 2 and 4, and the common factor is 2, so my formula is NH2. C5H12O, my subscripts are 5, 12, and 1, and there isn't a common factor between those three numbers, so I'm going to have to keep it the way it is. And that just means that my molecular formula is the same as my empirical formula. C10H22, 10 and 22 are the subscripts. The common factor is 2, so my empirical formula is C5H11. Let's talk about how to determine the empirical formula and the molecular formula. When we're determining the empirical formula, you want to convert your element masses to moles using molar masses. That means you have to use the periodic table. Then you want to divide each number by the smallest number of moles and set up a ratio. Step 3 says if it's necessary, you have to multiply by an integer to give the smallest whole number of ratio of subscripts, because the subscripts cannot be in decimal form or be fractions. When you're determining the molecular mass, or the molecular formula, you're going to have to compare the molecular mass to the empirical formula mass. You want to divide the two numbers, and that will give you the formula units, what you multiply the empirical formula by. Let's see an example. Write the molecular formula of a compound that has a molar mass of 316.25 grams per mole, and the composition of phosphorus 39.18% and sulfur 60.82%. Now these are mass percentage of a whole, so we can go ahead and think of these percents as grams. So step 1 says we have to convert our masses to moles, so that's what we want to do. So you want to convert gram to moles. I have 39.18 grams of phosphorus. If grams of phosphorus is in the numerator, then grams of phosphorus has to go in the denominator. And don't forget to use the periodic table for this. And I'm going to do the same thing for sulfur. Then step 2 says to set up a ratio so that you can compare the number of moles. So I'm going to set up a ratio now, and I'm going to compare the number of moles of phosphorus to the number of moles of sulfur. I'm going to divide by the smallest number of moles on both sides for all of the elements in the composition. And I'm going to get a 1 to about 1.5. Now, we can't keep decimals or fractions in the subscripts, so we're going to have to multiply by an integer to give us the smallest whole number ratio of subscripts. So if we multiply by 2 for all of the elements in this compound, we're going to get a 2 to 3 ratio. That means that the empirical formula is P2S3. But they're asking for the molecular formula, so I'm going to have to take this a little bit further. I'm going to go ahead and determine the empirical molar mass. And because I've done my work carefully, I don't need to keep referring to the periodic table. I can look at my work and get these molar masses. So there's 3 sulfurs, 3 times 32.06. We already used this in our conversion. And there's 2 phosphorus. Now that I have my empirical molar mass, I can go ahead and put it into that formula that compares the molecular molar mass over the empirical molar mass, and this gives me my units of N. My molecular molar mass is in my story problem, 316.25, so I can go ahead and put that in. My empirical molar mass, we just calculated, and this gives me a factor of 2. So what this means is I take my empirical formula and I multiply that by a factor of 2. So my molecular formula is P4S6. Let's take a look at another example. Determine the molecular formula of compound X with a molar mass of 266.4 grams per mole and the composition of aluminum 20.24% and chlorine 79.76%. The first thing you want to do is convert your grams to moles. So I have 20.24 grams of aluminum and I'm going to do the same thing with chlorine. And then I'm going to set up a ratio so that I can compare the number of moles. So I'm going to compare aluminum to chlorine. I'm going to divide by the smallest number. And I'm going to get a 1 to 3 ratio. These are already in whole numbers, so I don't have to multiply by an integer. I can go ahead and go straight to my empirical formula. My empirical formula is Al1Cl3. But the question is asking to determine the molecular formula. So from my empirical formula, I'm going to have to determine the empirical formula molar mass. I'm going to have to use the periodic table, which is already in my conversions, 3 times chlorine and 1 times aluminum. This will give me 133.33 grams per mole. Now that I have my empirical molar mass and I have my molecular molar mass from my story problem, I can go ahead and plug into a formula. Molecular molar mass over empirical molar mass equals to N. My molecular molar mass is 266.4 and my empirical molar mass is 133.33. So N equals 2. So now I have to multiply that by a factor of 2. I have to multiply the empirical formula by a factor of 2. So my molecular formula is Al2Cl6. Final answer. Good luck and keep practicing.